Okay, so next we're going to take a look at what can we do when we are going to solve algebraically. We're looking still for the intersection or the parallel no solution, but to do so we need to think about using substitution and elimination. Those are our two methods for algebraically solving. Now, I want you to think back. You can always use substitution, you can always use elimination, but they have instances where they are easier. So for instance, we're going to start with number 7 and we're going to use elimination because both problems are already in standard form. When the two equations given to you are in the same format, then elimination is typically the fastest or the easiest way to work. So elimination, I'm just going to add these two equations together. And adding them will take away one of my variables, and I know that I'm going to eliminate the y here because when I add a positive y and a negative y, well, positive 1y minus 1y is 0. So I'm just going to put these together. I'm going to add them. X and x is 2x. My y's are going to be eliminated. Negative 4 and 2 is negative 2. Now with just x, it's easy to solve to find x. X is negative 1. Well, if I know x, I can go find y. Now here it doesn't matter which equation you use. You can pick whichever one you'd like. So I'm going to use the top one. I'm going to say, well, that means that negative 1 instead of x plus y equals negative 4. Solving for y, so I'm going to add the 1 to both sides. And y is going to equal, make that look like a y that comes like an x. Y is going to equal negative 3. So my solution using elimination here is negative 1, negative 3. If you wanted to, could you graph that to check that? Sure, absolutely. Number 8, I have x plus y equals 4. I have 2x minus 5y equals 15. And the first thing I notice right off the bat is they're both in standard form. So elimination would be the most direct or the fastest way to put these together. I do have some options here that I could use, but what I want to do is I actually want to get two coefficients to be the exact same so that they will just subtract out. So I think what I'll do is the x is 2, this has a 1. I'm just going to multiply the top by negative 2 all the way across. And then I'm going to rewrite this. So this will become, remember we're distributing, so negative 2x minus 2y equals negative 8. Now, I don't need to change the bottom because I wanted to get the negative 2x and the 2x to be opposite of each other. So I'm just going to rewrite it. And now we're just going to add these up. So negative 2x and 2x, that will go to nothing. Negative 2y, negative 5y, negative 7y equals, and negative 8 and positive 15, that would be positive 7. We're adding. And then we'll divide both sides by negative 7, and y will equal, well, 7 divided by negative 7 is negative 1. So now I know y. If I know y, I can go find x. Does not matter which equation you use, but I'm going to use the easiest one. I think that x plus y equals 4 is the easiest. I'm going to say, well, that means that x plus negative 1 or x minus 1 equals 4. I'm going to, of course, add 1 to both sides, and that means that x equals 5. So my solution set here is x is 5, y is negative 1. Okay, let's flip the page and take a look at another one. Okay, so here for number 9, I have 4x plus 3y equals negative 1, and I have 5x plus 4y equals 1. And I notice right off the bat that the 4's and 5's don't line up, and the 3's and 4's don't line up. So what I'm going to do is I'm going to multiply the top by one coefficient, and I'm also going to multiply the bottom by a different. So let's say we want to get rid of the y's. So I'm going to multiply the top by 4, and then I'm going to multiply the bottom by 3. So I'm going to multiply the top by 4 and get a new equation that says 16x plus 12y equals negative 4. Now, I want this here, this 4y, to be a negative 12y, so I'm going to multiply the whole bottom by negative 3. That would give me negative 15x minus 12y, which is what I want. I want these to be opposites, equals negative 3. And now we're just going to combine them together. So this becomes x, so that's 1x. This is going to go away because we've eliminated the y's, and negative 4 minus 3 is negative 7. Well, look, I already know x. So if I know x, well, let's go plug it in and find y. I'm just going to use the top equation here, so that would be 4 times negative 7 plus 3y equals negative 1. Negative 28 plus 3y equals negative 1. Two-step equation now. We're going to add the 28 to both sides. 3y is now going to equal 27. We're going to divide both sides by 3, and y will equal 9. So my solution is going to be negative 7 and 9. All right, number 10. Number 10 says I have y equals 4x plus 2 and y equals x minus 1. Well, those are in the same format. They're both in y equals mx plus b, but because they're in the same format, I should be able to just eliminate very quickly. So I have y over y. Those have the same number 1, but I need to change 1 to be negative. So I'm going to multiply this entire bottom by a negative so that I can get a opposite. Rewrite the top, rewrite the bottom after I distribute the negative. And I can just put it together. Y minus y, they eliminate. But be careful when you eliminate and it's on its side by itself. We are still going to need a 0 there. We can't have an empty space. So 3x plus 3. Still solving for x, we're going to subtract 3 from both sides, so negative 3 equals 3x. Divide by 3, and x will equal negative 1. Halfway there, if we know x, now we can go find y. Doesn't matter which one we use. The bottom one looks a little easier. I'm going to say, well, that means that y equals negative 1 minus 1, or y is going to equal negative 2. So my solution is negative 1 for x and negative 2 for y. Now, when we started, I said we could use substitution or elimination. And thus far, all 4 problems were set up to where they were in the same format. They were all in standard form, or both of your equations were given to you in slope-intercept. But you can see in number 11, they're not in the same format. I have x equals 2y minus 3, and then I have 2x minus 3y equals negative 5. And the key here is that the x is already by itself. So since I already know what x is, this is what x is. X is 2y minus 3, right? And because x is 2y minus 3, I'm just going to plug that information in for x and solve for y. So let me rewrite this. This is going to be 2. So I'm going to open up parentheses and put in the 2y minus 3. Minus 3y equals negative 5. All the x's have been eliminated at this point. Now we're just solving a multi-step equation. We're going to start with distribution. So 4y minus 6 minus 3y equals negative 5. Combine like terms. Y minus 6 equals negative 5. Add the 6 to both sides. And y will equal 1. Halfway there, I need to go find x, so I'm going to plug that in. So x is going to equal 2 times 1 minus 3. So x would equal 2 minus 3, or x would equal negative 1. So my solution is negative 1, 1. 12, much like 11. Except instead of knowing what x is, I just know what y is. So I'm going to put this exactly where the y is, rewrite this problem. So 2x plus 3 in parentheses, 5x minus 27 equals 4. We're going to start with distribution. So the 2x drops down. 3 times 5x is 15x. 3 times negative 27, negative 81 equals 4. Not ready to move yet. We're still combining, putting things easier. So 2 and 15 equals 17x minus 81 still equals 4. Now it's a two-step. Add the 81 to both sides. So 17x equals 85. Divide by the 17. And x is going to equal 5. Well, again, if I know x, I can go find y. So I'm going to plug that in. I'm going to plug it into that bottom one. So y equals 5 times 5 minus 27. So y would equal 25 minus 27, or y would equal negative 2. Set that up. Make sure that we have that set up properly. My x is 5, my y is -2, and there is my solution. That's where they would crisscross or intersect if I had them drawn up on a graph. So again, substitution and elimination. We use elimination anytime they're in the same format. So I have both of them in standard form, or they're both in y = mx + b, then it's usually the fastest way is to eliminate. If one is solved for x or one is solved for y and the other is not, then I can simply plug that value in and eliminate from that direction.